Sports mechanics and biomechanics might sound like complex terms, but they are all about understanding how our bodies move and perform in sports. Think about how a soccer player kicks a ball or how a gymnast flips in the air. These actions are governed by principles of physics and human anatomy. Sports mechanics focuses on the physical aspects of movement, while biomechanics applies these principles to the human body. Biomechanics helps us understand the forces acting on an athlete's body and how they can be optimized for better performance. It combines knowledge from biology, physics, engineering, and more. By studying biomechanics, coaches and athletes can improve techniques, prevent injuries, and enhance overall performance. Imagine a basketball player jumping for a shot. Biomechanics can analyze the jump's height, body angle, and force applied. This analysis helps in tweaking movements for better efficiency. Essentially, sports mechanics and biomechanics unlock the secrets behind peak athletic performance, making it a fascinating field. Gravity is a constant force that acts on all objects, including athletes. It's what pulls us back down when we jump. In sports, understanding gravity is crucial. For instance, in high jump events, athletes need to overcome gravity to achieve greater heights. They do this by applying force against the ground, which propels them upward. Air resistance is another external force that affects athletes. It's the force air exerts against an object moving through it. Cyclists and runners often face air resistance, which can slow them down. Wearing streamlined clothing reduces this drag, helping them move faster. Swimmers also deal with similar resistance, but in water, known as hydrodynamics. For example, sprinters use starting blocks to push off with maximum force, overcoming inertia and minimizing air resistance at the start. Understanding these forces allows athletes to adjust their techniques and gear to improve performance. Knowledge of gravity and air resistance is crucial for fine-tuning athletic movements and strategies. Athletes continually apply forces to move, jump, throw, or sprint. These forces determine how well they perform. For instance, a tennis player applies force to the racket to hit the ball. The speed and direction of the ball depend on the force and angle of the hit. The right combination leads to powerful and accurate shots. In sports, forces can be internal or external. Internal forces are generated by muscles and joints within the body. External forces come from outside the body, like ground reaction force when running. Efficient use of these forces is key to athletic success. A sprinter applies force against the track, while a diver uses body force to control movement in the air. Coaches use force plates and motion capture systems to measure these forces and optimize training. For example, improving a football kicker's technique involves analyzing the force applied to the ball and adjusting the stance and swing. By fine-tuning these forces, athletes can enhance their performance and reduce injury risks. Isaac Newton's laws of motion are fundamental in sports mechanics. The first law, inertia, states that an object in motion stays in motion unless acted upon by an external force. This explains why a soccer ball keeps rolling until friction or another force stops it. The second law, acceleration, relates to how force and mass affect an object's motion. More force means more acceleration. The third law, action and reaction, is crucial in sports. For every action, there's an equal and opposite reaction. When a basketball player jumps, they push against the floor, and the floor pushes back with equal force, propelling them upward. These laws help in understanding and improving athletic movements. For example, in weightlifting, the lifter applies force to the weights. According to the second law, the heavier the weights, the more force needed to lift them. By understanding these laws, athletes can refine techniques to maximize their performance, whether it's in running, jumping, or throwing. This is Section 5, Importance of Mechanical Principles in Sports. Mechanical principles in sports are vital for efficiency and performance. These principles include leverage, momentum, and balance. Leverage is used in sports like baseball, where the bat acts as a lever to hit the ball. Momentum, the product of mass and velocity, is key in sports like football, where players use their body mass and speed to tackle opponents. Balance is another important principle. Gymnasts, for example, need excellent balance to perform routines on the balance beam. Understanding these principles helps athletes enhance their techniques and optimize their movements. It also aids in designing better sports equipment. For instance, modern tennis rackets are designed with an understanding of leverage and momentum. They are lighter and stronger, allowing players to hit with more power and control. By applying mechanical principles, athletes and coaches can improve training methods, equipment design, and overall athletic performance. Section 6. Understanding gravity to improve athletic technique. Gravity plays a significant role in sports, influencing how athletes move and perform. For instance, in basketball, players must understand how to use gravity to their advantage when shooting. By jumping and releasing the ball at the right moment, they can achieve better accuracy and height. High jumpers also use gravity to their benefit by arching their bodies over the bar, reducing the height they need to clear. Understanding gravity helps athletes in many sports, from gymnastics to skiing. Gymnasts use gravity to control their flips and twists, while skiers use it to maintain balance and speed on slopes. Coaches teach athletes how to work with gravity, not against it, to enhance performance. For example, in pole vaulting, the athlete uses the pole to convert horizontal speed into vertical lift, overcoming gravity. By mastering techniques to control and utilize gravity, athletes can achieve new heights in their performance. Gravity becomes an ally rather than an obstacle. Section 7. Benefits of sports mechanics knowledge. Knowledge of sports mechanics offers numerous benefits. It improves performance by helping athletes understand and optimize their movements. For instance, sprinters can analyze their running form to reduce drag and increase speed. This knowledge also enhances equipment efficiency. Engineers design better gear, like lighter shoes and more aerodynamic helmets, based on mechanical principles. Safety is another significant benefit. Understanding forces and motion helps in creating safer training programs and equipment. This reduces the risk of injuries. Coaches can tailor exercises to strengthen specific muscles and joints, preventing common sports injuries. Sports mechanics knowledge also contributes to better rehabilitation programs for injured athletes. By understanding how the body moves and heals, therapists can design effective recovery plans. Overall, this knowledge leads to improved performance, safer sporting environments, and better designed equipment. Section 8. Types of motion: linear, angular, and general. Motion in sports can be classified into 3 types: linear, angular, and general. Linear motion occurs when an object or athlete moves in a straight line. For example, a sprinter running down the track exhibits linear motion. Angular motion involves rotation around an axis. A basketball spinning in the air after a shot is an example of angular motion. General motion is a combination of linear and angular motion. Most athletic movements fall into this category. For instance, a gymnast performing a floor routine combines linear movements like running with angular movements such as flips and spins. Understanding these types of motion helps in analyzing and improving athletic techniques. Coaches use this knowledge to design drills that enhance specific types of motion. For example, training a swimmer involves improving both their linear motion, like swimming straight, and angular motion, such as turning at the wall. Understanding and applying these types of motion leads to more effective training and better performance. Section 9. Measurement perspectives: qualitative and quantitative. In sports mechanics, measurements can be qualitative or quantitative. Qualitative measurements are descriptive and often subjective. Coaches use them to evaluate an athlete's technique based on observation. For example, a coach might note that a sprinter's form looks smooth and efficient. These observations help in making immediate adjustments. Quantitative measurements, on the other hand, are numerical and objective. They provide precise data on various aspects of performance, such as speed, force, and distance. Tools like motion capture systems and force plates help in gathering quantitative data. This data is crucial for detailed analysis and long-term improvement. For instance, a high jumper's performance can be analyzed qualitatively by observing their jump technique and quantitatively by measuring the height cleared. Combining both perspectives gives a comprehensive understanding of performance. This holistic approach helps in refining techniques and achieving better results. Section 10. Planes of movement and joint motion types. Understanding planes of movement and joint motion types is essential in sports mechanics. There are three main planes of movement: sagittal, frontal, and transverse. The sagittal plane divides the body into left and right halves. Movements like running and squatting occur in this plane. The frontal plane divides the body into front and back halves. Movements like jumping jacks occur in this plane. The transverse plane divides the body into top and bottom halves. Movements like twisting and rotating occur in this plane. Joint motions are classified as flexion, extension, abduction, adduction, and rotation. Flexion and extension occur in the sagittal plane, while abduction and adduction occur in the frontal plane. Rotation occurs in the transverse plane. For example, a swimmer uses all three planes of movement during different strokes. Understanding these planes and joint motions helps in designing effective training programs. It also aids in injury prevention by ensuring balanced and comprehensive workouts. Section 11. Muscle contractions, concentric, eccentric, and isometric. Muscle contractions play a crucial role in athletic performance. There are three types: concentric, eccentric, and isometric. Concentric contractions occur when a muscle shortens while generating force. For example, lifting a dumbbell involves concentric contraction of the biceps. Eccentric contractions occur when a muscle lengthens while generating force, like lowering the dumbbell. Isometric contractions occur when a muscle generates force without changing length. Holding a plank position involves isometric contraction of the core muscles. Each type of contraction is important in different sports and exercises. Understanding them helps in designing effective training routines. For instance, runners use concentric contractions to propel forward, eccentric contractions to control landing, and isometric contractions to stabilize the body. Training programs that incorporate all three types of contractions lead to balanced muscle development and improved performance. Section 12. Use simple examples and analogies for clarity. Using simple examples and analogies makes understanding sports mechanics easier. Imagine muscles as rubber bands. When you stretch a rubber band and let go, it snaps back with force. This is similar to how muscles work. In a baseball pitch, the arm acts like a lever, with the shoulder as the fulcrum. The force applied by the muscles determines the speed and accuracy of the pitch. Think of air resistance like riding a bike against the wind. The harder the wind blows, the more effort you need to pedal. Wearing streamlined clothing reduces this resistance, making it easier to move faster. These analogies help in visualizing complex concepts in a simple and relatable way. For example, in swimming, the water's resistance is like moving through thick syrup. Swimmers streamline their bodies to minimize this resistance, gliding through the water more efficiently. Simple analogies make sports mechanics accessible and understandable for everyone. Section 13. Relate the content to everyday sports and activities. Relating sports mechanics to everyday sports and activities makes the concepts more relatable. For instance, playing basketball involves understanding balance, gravity, and force. When you jump to make a shot, you use your body's force against the ground to overcome gravity. The angle and force of your shot determine if the ball goes into the hoop. Running is another everyday activity where sports mechanics play a role. Your stride length, running form, and the force applied with each step affect your speed and efficiency. Understanding these mechanics can help improve your running technique, making you faster and reducing the risk of injury. Even simple activities like playing catch involve sports mechanics. The force and angle at which you throw the ball determine its speed and trajectory. By understanding and applying sports mechanics principles, you can enhance your performance in everyday sports and activities, making them more enjoyable and effective.